All right, hey guys, Mr. Judson here. So I may have figured out something that'll help us out with that issue that we're having. So I'll try it with you guys tomorrow and we'll see if we've got things fixed. So here's how far we made it. We got these 3 points written in here. We already had all the points on our x and our y axis. And what we're saying is that if you do the cosine of 30, that gives you these x coordinates. All right, so again, just to test this and make sure, I'll pull the calculator up. I'm going to do cosine of 60 degrees. So cosine 60. And there I get 0.5, 1/2, the x coordinate. If I do cosine of 45 degrees, that's the decimal equivalent of root 2 over 2. Okay? And if I do sine of 45, see, I get the exact same thing. Both of those decimal numbers are the square root of 2 divided by 2. See? You look at all 3 of those decimals, they're exactly the same. All right? So these 2 tick marks, we're not going to be able to find coordinates for those yet. We're going to have to put that off until later on in the semester when we learn a few things. But we will eventually figure out sine and cosine of that as well. What I want to do is I want to get the rest of these middle 3 tick marks filled in around this unit circle. So, you know, if you think about it, this x and y coordinate for this second tick mark is exactly the same x and y coordinate over here because of symmetry. It's just that our x coordinate is going to be negative, right? So if I want to take that point and switch it over here, my x coordinate becomes a negative root 3 over 2, comma 1/2. And the same thing with this one. If I switch this over to here, then the coordinates for that point are going to be a negative root 2 over 2, comma root 2 over 2. And then for this coordinate, this will be the same as this one. It'll just be a negative 1/2 for the x value. So a negative 1/2, comma root 3 over 2. And I could do the same thing down to here. If I just kind of reflect all this stuff down, the coordinates for this point would be the same as, this one right here. It's just that my y coordinate, instead of going up, I'm going down 1/2 a unit. So both of these will be negative here. So a negative root 3 over 2, comma negative 1/2. If I do this middle tick mark here, that'll be these coordinates, except instead of going up root 2 over 2, I'm going down. So my y coordinate will become negative down here. So a negative root 2 over 2, comma negative root 2 over 2. And then the same thing with the coordinates for this point. You know, I came over 1/2 a unit, I go up root 3 over 2. Remember, this is up 1 unit right here. Root 3 over 2 was 0.866. So I'm not quite going up a full unit. I'm going a little bit less than that, which that's what that y coordinate is. Okay, but now I'm going down that distance. So this point right here will have the coordinates negative 1/2, comma negative root 3 over 2. And now the coordinates for these 3 tick marks, I can kind of do the same thing here. I can just think if I'm going to reflect these points down, all the y coordinates would just become negative. So this point right here would be the same as this one. I would have root 3 over 2 and then a negative 1/2. Flip this one down to here, I've got, for the coordinates for that point, I've got root 2 over 2, comma negative root 2 over 2. And for this point right here, I've got 1/2, comma negative root 3 over 2. All right, so you can kind of start to tell that our unit circle is getting a little bit crowded, all right? There's some really nice pictures of the unit circle on the internet. I found this one, which is actually right out of our book. I mean, look at that. If I make this a little bit bigger, that's exactly what we just wrote down, but it's kind of nice and neat. All right? You can find these pictures on the internet. Just Google unit circle. And then as soon as you find one of these circles, use your little clipping tool. If you don't have that down here on your taskbar, you can go over here and type clip, I think it's clipping tool. And all you do is just draw a picture around this and you can copy it on any piece of paper you want. Okay? So anyway, there's all those numbers that we just wrote in to our unit circle. So if we want to test these, let me go back to this picture. Let's see, if I go all the way around to this angle right here, this was 270 plus another 30. This is the angle, oops, 300 degrees. So if I go to my calculator and I do the cosine of 300, should get 1/2. 0.5, 1/2. What if I went this direction? This is a negative 60 degrees. What if I said cosine of a negative 60 degrees? Still 1/2. What's this angle right here? If I go 90 degrees and then another 45 to get to the middle, that would be 135. And if I do the cosine of 135, I should get a negative, what was that, 0.707, something like that? So cosine of 135, yep, negative 0.707, that's a negative root 2 over 2. If I do the sine of 135, there I'm getting a positive root 2 over 2. Just double check again. If I do the square root of 2 divided by 2, yep, same decimal. Okay? So this is the important thing about what we're trying to do today, is I want for you guys to realize that the x-coordinate always gives you the cosine of whatever angle you're on. Doesn't matter if it's in radians or degrees, it gives you the value of the cosine. And the y-coordinate always gives you the value of the sine of any angle, whether it's degrees or radians, whether you're going forward or backwards, doesn't matter. Right? If I go around twice, that's a 720, and I do the cosine of 720 degrees, I should get 1. Right? There it is. If I do the sine of 720, I should get 0. Sine 720. There we go, 0. All right. So what if I was to ask you guys a question like this? What's the tangent of 120 degrees? And what we want to do is we want to use our unit circle as a way to figure this out. Okay? Well, do you guys remember this? So, ka, toa. Do you guys remember that? Tangent means opposite over adjacent. Well, if you think about, when I did this, I drew in a triangle that was a 30, 60, 90 degree triangle. And the length of this side is my x-coordinate, root 3 over 2. And the length of this side was my y-coordinate, right? to get those coordinates, we started here at the origin, we went out root 3 over 2 and up 1/2. Those are the coordinates at that point. Or we started here, we went 0.866 units this way, 0.5 units this way. That's the decimal equivalent of these, all right? So if I want to figure out the tangent, and tangent is opposite over adjacent, well, opposite is that coordinate, adjacent is this coordinate, so I could say that tangent of some angle is equal to the y-coordinate over the x-coordinate. Right? Does that make sense? Tangent is opposite over adjacent. Well, the y-coordinate is just the value of the sine of theta, and the x-coordinate is just the cosine of theta. So what I want to be able to do is say that tangent of theta is equal to sine theta over cosine theta. That's a pretty important piece of information right there. So now when I look at that, I've already got all these numbers written down, so I know sines and cosines of all of these different angles, okay? If I want to find a tangent, all I have to do is just do the sine divided by the cosine. Sine divided by cosine. Sine divided by cosine. Sine divided by cosine. Uh-oh. I just divided by 0. That's a problem, right? The tangent is undefined right here. It's also undefined right here. Okay? But I can find the tangent of any of these by just doing the y-coordinate divided by the x-coordinate. So if I asked you guys, what's the tangent of 120? Well, I just need to go to wherever 120 degrees is. So here's 90 plus 30, that puts me right here. If I want the answer, I just need to do root 3 over 2 divided by a negative 1/2. So root 3 over 2 divided by a negative 1/2. And then how do you divide by fractions? Well, you got to flip it over and multiply. So this really equals root 3 over 2 times, if I flip this over, I get 2 over negative 1. Those 2's will cancel. And so what I get is this divided by a negative 1, which is just a negative root 3. There's the tangent of 120 degrees right there. That's my exact answer. Let's check it with a calculator, see if we did it right. If I go tangent of 120, there's what I get for a decimal, a negative 1.732. What's a negative square root of 3 equal to? Negative root 3. Look at that, exact same decimal, digit for digit. All right, you guys, I'm going to stop there. No assignment today. We've got a lot of work to do here still before I can give you an assignment. We're not quite there yet. But this is what I'm going to get done in 6 periods, so I've at least got you guys caught up. All right?